Hi friends, today we are starting chapter 3 and we're going to look at dividing fractions. We're going to start off with the example. You have 3 candy bars. You break each bar into fifths to share with friends. How many friends get a piece? So the problem that's being asked here, the math problem, is we're taking 3, we're starting with 3, and we're dividing into pieces that are 1/5 of a bar big, and we want to know how many 1/5s are in 3. So we are going to bar model this. So I'm going to draw my 3 candy bars. And then each candy bar I'm going to divide into fifths. I do that by drawing 4 lines. So we have a fifth, a fifth, 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 fifth. And I'm going to continue doing that with each of the candy bars. And we can get the answer simply by adding up all the pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So from this we see that 3 divided by 1/5 is equal to 15. Now this might look, or maybe you see something that's happening here. When I see 3 divided by 1/5, I actually see multiplication. It looks like we're just doing 3 times 5 is 15, and that is completely correct. So let's use the same idea. 3 divided by 1/5, 7 divided by 1/4. I'm not going to draw it out this time, but we're going to use the same idea that we did with, so 7 divided by 1/4. You can simply multiply the 7 times the 4, and this is 28. So this leads us to a new idea, which is the idea of a reciprocal. A reciprocal is when you flip a fraction. So if we start with the fraction 2/3, the reciprocal is 3/2. And the reason we talk about reciprocals is because when we're doing a problem like 7 divided by 1/4, it's like we're actually starting with 7 and we're multiplying by the reciprocal of 1/4, which is 4/1. And we're just multiplying 7 times 4, which is 28. So the steps we're going to follow are, this is for dividing fractions, you might want to write this down. Step 1, the first number, we're going to keep it the same. We're not going to change anything on the first number. Then we're going to change division to multiplication. And then we're going to take the reciprocal of the second fraction. And this is the new problem that we are going to solve. So instead of dividing fractions, we're actually going to multiply by the reciprocal. So let's do a few examples. Example 1, we went to 3/5 divided by 11/15. Now this would be kind of tricky to bar model, and that's why we use the algorithm that we just talked about. So the first number, the 3/5, we keep that the same. We're never going to change that first number. Division, we're going to change that to multiplication. The second number, 11/15, we are going to flip that, take the reciprocal and make it 15/11. Now when we multiply fractions, we just go straight across, 3 times 15, 5 times 11. But it's always a good idea before you multiply to look diagonal. And I see that 5 and the 15, and we can simplify that before we multiply. So 5 and 15 both can be divided by 5. 5 divided by 5 is 1. 15 divided by 5 is 3. And now we multiply straight across. 3 times 3 is 9. 1 times 11 is 11. So the answer is 9. 11ths. Next example, 2/3 divided by 10/13. First number stays the same, 2/3. Oops. We change our division to multiplication. And the second number, the 10/13, we're going to flip that, take the reciprocal and make it 13/10. Before we multiply, we're going to look diagonal, see if we can do any simplifying. 3 and 13, they don't share any common factors other than 1, so there's nothing we can do there. But 2 and 10 both share a common factor of 2. So I'm going to divide those both by 2. 2 divided by 2 is 1. 10 divided by 2 is 5. Then we multiply straight across. 1 times 13 is 13. 3 times 5 is 15. 13/15. Next example. What if we have 6 divided by 2/7? First number we're not going to change, but I'm going to write it as a fraction. I'm going to make that 6/1. We're going to change division to multiplication, and then take the reciprocal of the second number. I look to see if I can do any simplifying before I multiply. 6 and 2 can both be divided by 2, so this becomes 3 and 1. And then I multiply across. 3 times 7 is 21. 1 times 1 is 1. I'm never going to leave an answer with 1 in the denominator, because 21/1, when simplified, is just 21. Last example. What if we're dealing with a mixed number? 5 1/4 divided by 3 1/2. Okay, mixed numbers are kind of icky to work with, so before we do anything, we're going to change them into fractions greater than 1. To do that, we start at the 4, we multiply, we add the 1, and then the denominator stays the same. So 4 times 5 is 20, plus 1 is 21. So it's 21/4 divided by 2 times 3 is 6, plus 1 is 7, so it's 7/2. Now we use the algorithm we talked about before. The first fraction stays the same. Change division to multiplication. Reciprocal of the second fraction. And then we look for simplifying opportunities. Ooh, here we have 2 opportunities. 21 and 7 can both be divided by 7. 21 divided by 7 is 3. 7 divided by 7 is 1. And then 2 and 4 can both be divided by 2. So we get 1 and 2. We multiply across. 3 times 1 is 3. 2 times 1 is 2. Now we can either leave it as 3/2, or we can change that to a mixed number, and that is 1 1/2. And that is all for today. Please email me if you have any questions. Thank you.